But the challenge is going forward, solar's not enough anymore. Particularly in markets like California with the NEM3 changes, what's happening is utilities are outsmarting solar in some of these markets, and they're doing that with rate changes. They're hitting customers with peak demand charges, that worst 15-minute mistake of the billing period that can dominate the bill, and time of use energy charges in ways that, look, solar is producing often when the value of production is the lowest. And that creates a significant challenge both for people developing solar projects. And what do you need to do? Well, you've got to start paying attention to load profiles in the building.
Are you speeding the energy transition? Here at the Clean Power Hour, our host Tim Montague bring you the best in solar, batteries, and clean technologies every week. Want to go deeper into decarbonization? We do too. We're here to help you understand and command the commercial, residential, and utility solar, wind, and storage industries. So let's get to it. Together we can speed the energy transition.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 8 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more. Welcome, everyone, to today's expert panel discussion, Commercial Solar and Battery Storage, Making Smart Energy Solutions Work for Your Facility. I'm Tim Montague, host of the Clean Power Hour. Please check out all of our content at cleanpowerhour.com. Today's webinar is brought to you by Chint Power Systems. Check out all of their three-phase string inverters and battery storage solutions for C&I and utility applications at chintpowersystems.com. I will be your moderator for today's session. Before we dive in, a few quick housekeeping items. The session is being recorded and will be available for replay at cleanpowerhour.com. You'll also get an email notification about the recording, which will be posted sometime next week. We'll have Q&A during and after the session or towards the end of the session. So please do put your questions into the Q&A feature in the Zoom at the bottom of your interface. Feel free to connect with our panelists on LinkedIn. I have put their profiles in the chat there for you, and they are all looking forward to hearing from you directly on LinkedIn. Today, we're going to explore how commercial facilities can implement solar, battery storage, and building management systems to lower energy costs. We'll take a detailed look at a project called Rancho Santa Margarita, a Toyota facility there in California, which features a 451 kW rooftop solar project and a 125 kW, 279 kWh energy storage facility. Let me introduce our distinguished panelists, our distinguished panel of experts today. First, we have Ryan Ferrero, National Director at Freedom Solar. Ryan leads industry electrification for commercial facilities across all 50 states. And as a former auto dealership principal who received numerous industry awards, Ryan brings firsthand knowledge of how renewable energy can transform commercial operations. He's even presented to the U.S. Senate and has been featured on CNN, Fox, NBC, and in Fast Company. Next is Casey Miller, CEO of Elexity, a startup in Bend, Oregon, specializing in energy control software. Casey brings over 20 years of experience in business creation, sales leadership, and product development. Under his leadership, Elexity has developed innovative solutions for coordinating real-time optimization of solar, HVAC, batteries, EV charging, and grid services in commercial buildings. And finally, we have Anton Patton, VP of Product Management at CPS America. Based in Pleasanton, California, Anton leads CPS's product and engineering activities, including support for current product lines and development of new solutions for the U.S. market. His background includes extensive technical experience in C&I solar PV, and energy storage projects. Today, we'll start with practical insights for facility owners and managers, and then move into a deeper technical discussion for those interested in implementation details. And by the end of this session, you should have a clear understanding of the immediate financial benefits of solar and battery storage, how these technologies work together to maximize savings, practical considerations for facility owners, strategies for navigating utility rate structures, what makes a facility ideal for these solutions, and how to evaluate warranties, maintenance, and long-term reliability. Let's begin with a brief overview of commercial solar and storage as it stands here in March 2025. Ryan, give us, given your experience with automotive dealerships and other commercial clients, what are the most compelling immediate financial benefits, the value stack, so to speak, that you're seeing for businesses who are implementing solar plus storage in 2025? And can you share some specific ROI metrics from recent projects?
Yep. Sounds good, Tim. Thank you. First, want to say when I got into this space after my life as a car guy, and out of Boulder, Colorado, it was sustainability was pretty preachy. We wanted to try and convert everyone to be an environmentalist and hug trees and eat granola and that sort of thing. And it was pretty quick to learn that the only way you're going to scale green things is the financial argument. We can all agree, left side of the aisle, right side of the aisle, that if the money makes sense, we're probably going to do it. So for commercial solar, that is a very important focus, is focus on the money. And if there's any environmental motivations, you just let that be the sugar on top and down the road. But in the meantime, how do you get immediate financial impact? And that's what's exciting about commercial solar. Obviously, you want a short payback. You want to leverage all eligible incentives, whether cash or tax. But you also have to think about, as you say, the value stack, Tim. You want to think about who wins on the go-forward basis. So if you have energy savings, if you're saving money with the battery from peak demand shaving, or if you're saving money by not paying the utility company as much, saving is not very inspiring. That word, you could save money by switching to Geico, right? So what we really help commercial owners leverage is to convert that savings into income. So essentially what you do is that accounts payable person is going to cut 2 checks each month for the electricity that's consumed, one that's going to the utility company, and then one to the entity that owns the solar and the storage assets. So you're, again, diverting what would have gone to the utility company as a passive income stream. So when you put that all together, the most immediate financial benefits are obviously going to be what you can get with investment tax credits, bonus depreciation, any cash payments or grants. But you also have an aggregate of savings that it's fine if they let it hit the financial statement and their P&L has a reduction in fixed expenses. But where everyone stands to attention is when you see, $2, $4, $6 million of savings become an income stream. Well, now that gets pretty exciting.
Yeah, in my experience, solar alone is a nice ROI, right? You put some money in for the facility, it pays back over 5 to 10 years, and then the rest is gravy. With solar plus storage, you have the potential of multiplying the ROI literally by a factor of 3 plus. And yes, the CapEx is greater, but the ROI is much greater. And that is the value proposition and why solar plus storage is the peanut butter and jelly. And then the whole sandwich is with our friend Casey Miller here with Elexity's building control systems. So Casey, from your perspective as an energy management software provider, how are you seeing the integration of building management systems with solar and storage change the financial equation for commercial facilities? And what kind of operational savings are your clients experiencing beyond the direct energy cost reduction?
Thanks, Tim, and thanks everybody who's attending. I think we're looking forward to this discussion. I'm going to be a bit controversial here to start. And before I do that, I'm going to give the context that I love this. We love solar at Elexity. In fact, part of our mission really is to expand solar in the C&I space. And I've worked for a long time with people like Anton, who you'll hear from, to make solar easy and more affordable and economical in the commercial industrial space. But the challenge is going forward, solar's not enough anymore. Particularly in markets like California with the NEM3 changes, what's happening is utilities are outsmarting solar in some of these markets, and they're doing that with rate changes. They're hitting customers with peak demand charges, that worst 15-minute mistake of the billing period that can dominate the bill, and time of use energy charges in ways that, look, solar is producing often when the value of production is the lowest. And that creates a significant challenge both for people developing solar projects. And what do you need to do? Well, you've got to start paying attention to load profiles in the building. Ideally, you're matching the solar output to the load profile, and you can't control solar. So what can you control? Well, you can control the loads, the usage in the building. At Elexity, we do that with batteries and with load control, real-time shifting of HVAC and EV chargers in commercial facilities. And when you match the load profile to solar production, then you get the kind of multipliers that you talked about, Tim. You get better ROI for the customer, you get improved payback periods. And we're seeing payback periods in California in particular for a battery and load control investment of as low as 3 years, right? And those are great numbers. To Ryan's point, show me the money, right? In these businesses, they need to see the dollars, and batteries combined with load control and solar are showing up and delivering. We'll talk about an example with Rancho Santa Margarita Toyota. But Tim, you also asked about other benefits of an energy management system. When you provide a solution to manage the load profile in a building and loads like HVAC and EV chargers, you're also giving these customers a platform to see, monitor, control, and manage everything in their facility. And there's other economic benefits that come with that. Ease of use, lower operational cost, improvements in the ability to maintain systems in a facility. And there's one more thing. When you control all those assets together, you can enable customers to participate in grid service programs. And Ryan talked about savings are nice, but what we think customers love are checks. So when you can extract a payment from a utility to a customer, that shows up as new revenue. Man, that's really fun to do. And we got to do that last week for one of our car dealership customers. So we're taking a different approach. Unfortunately, again, solar is not enough anymore in some markets. And batteries plus load control can really make a significant difference.
Well said. Well, Anton, CPS America provides the technical backbone for many of these systems. How have advances in inverter and storage technology over the past few years impacted the financial viability of commercial solar and storage projects? Are there specific technological breakthroughs that have been game changers?
Yeah, thanks, Tim. So CPS, we've been a leader in the commercial industrial space. We've deployed over 10 gigawatts of PV inverters to the US market. And with that, we've seen, a lot of different types of projects. We've worked with a lot of EPCs and developers, and we've seen a lot of the challenges that can be faced with these commercial projects. And we've gained a lot of knowledge there. And it's allowed us to grow with the industry and become a trusted partner, not just with our technical solutions, but with the reliable support and service that we pride ourselves on and we provide to our customers during the project design, installation, and operation of these systems. And thinking about the string inverter technology, so three-phase string inverters have made major impacts in the CNI solar PV space over the last 10, 15 years. And it's really enabled the commercial solar space to grow a lot bigger than it was really expected to be. And we're really excited to bring that string inverter technology to the energy storage space and kind of bring a lot of that value that's been seen with solar. Things like, the flexibility and compact solutions that have really evolved both in solar and now storage. Also, being able to scale these solutions and have short lead times, which obviously leads to projects being able to be developed a lot quicker than it would if you had to wait a year plus for the equipment needed for these installs. Several other technological advances that we've seen a big need for with the lessons learned over the years on storage side has been data communications. So remote capabilities of monitoring these systems, being able to remotely troubleshoot, diagnose without rolling trucks to the site has been critical. Higher efficiencies with the equipment, things like liquid cooling for batteries versus the traditional HVAC units, as well as, not just on the technology side, but the industry standards that have developed and evolved, a lot of the codes to make these systems safe. I think all of these advancements have impacted, the viability and financial value of these storage systems.
Great. So Ryan and Casey, let's talk about Rancho Santa Margarita Toyota. Walk us through the elements of this 451 kW project, solar project, and what were some of the challenges and solutions for the dealership as you understand them.
All right. Let me start and kind of hit you with a barrage of data points. First of all, when I first went and visited this store and got to know the ownership and the motivations, it was 102 degrees outside. Standing on the pavement was blistering hot. And of course, the retail environment that they have, those front doors are opening all the time, and that air conditioning is just firing away. I mean, it was crazy hot. And of course, there's a lot of glass with solar, heat gain coming in there too. So they needed to really attack not just what's happening with peak demand charges and all the year-over-year utility costs there, but just the environment that they're in. That June, July, August is incredibly reliant on air conditioning. So they took a holistic approach, and it was brilliant. It was a phased approach too. It was, kicking off with, all right, we know we need to get what's called a max fit. Let's get as much solar as we can up on the roof, ballasted systems, so we don't have to drill any holes in it. Although, let's get the expected life of the roof close to what the expected life is of the solar array. So they put a new roof up there with white TPO. So that white membrane helps with reflectivity and ambient lights. You get a little more bonus production on the panels. And then you're going to realize, well, wait a minute, solar's kind of dumb. It's just up there doing its thing. So we need to get software in there to optimize everything and understand the time of day and anticipate it with AI. So building management systems and Elexity started really turning the screws on shifting load with the HVAC. And then, well, wait a minute, we need to get a battery up there. Let's fill that up with free energy from the solar, or at night when energy is cheapest, and then drain that battery during those afternoon times. Even if the air conditioning is not running, they can run their compressors, very busy store. So what they ended up doing over the course of a few years, they didn't just wave a magic wand and do it all at once. They did things in what I think is brilliant, which is one step at a time, but know that in several years, you're going to have a machine that is really well tuned for the specific operations of the store, hours of the day, and they're now really insulated from pain from SoCal Edison and what they're running into with these explosively high peak demand charges out there.
So I'm putting the facility on screen. You can find it on Google. This Rancho Santa Margarita is a little bit south and east of Los Angeles, but so in Southern California. And Casey, tell us about the project from Alexity's perspective.
Yeah, well, Ryan did a great job of explaining it, and we love this customer. The owner, Jim, is progressive and wanted to invest in a whole energy management system, and he's done that. He's done that in stages like Ryan described. I think it was really smart. They made the decision to move forward with solar. But solar's a construction project. It takes some time to get permitting and get the wheels in motion. And while that was set in motion, they went ahead and invested in Alexity's HVAC load control platform. We put a meter in the building, we got eyes and ears on the building, and we began controlling HVAC to shave peak demand right away. It's a one-day install, no permits required, and they were immediately able to get benefit from that and see their energy use, see their energy production in one place. So that was smart, and that allowed them to clearly support the solar investment, and then with data, make an intelligent decision about what size battery they needed and what benefit that would bring. So just a great way to approach the project in phases. And now we are controlling the whole system. They're maximizing the benefit of solar. Got a battery that's reducing those peak time of use energy charges with Southern Cal Edison every day. HVAC load control that's clipping demand charges for them. We're soon to be installing our control EV chargers, and they'll have one platform to manage everything. Just really smart, and they took advantage of kind of phasing the projects.
I like to say Elexity turns your building into a battery. Is that a misnomer, do you think, or is that kind of what we're doing here, turning the building into a storage device?
Yeah, I mean, certainly when we put a battery in the building, we've got a battery, but we also treat the HVAC system like a thermal battery. I would simplify it to this. We use multiple tools to help customers buy low, sell high every day. Buy energy low, sell energy high.
Yeah.
Maximize the value of solar and flatten that load profile. And we do that with both a battery and our load control techniques. But yeah, sometimes, Tim, we talk about HVAC management as it's a small thermal battery that's in every building, and you can take advantage of that and pair it with a battery system and get more for your money.
And what we're really talking about here is attacking the duck curve, right? In California, where we have high penetration of solar, you get this belly, right, of the duck because the solar's cranking in the middle of the day. And so energy does get very cheap. And then as the sun goes down, energy goes up and demand goes up because people are going home and turning on their kitchens and their HVAC. And then you utilize the battery or the battery plus, right, in Alexity's case. So, Anton, what would you like to add in terms of what our audience should know and understand about implementing solar storage and building management systems from CPS's perspective?
Yeah, I mean, I think one message I'd like to reiterate is, implementing solar and storage for these projects is not as complicated as it may seem, or at least it doesn't have to be, especially with, a turnkey hardware solution and a good software controls package like Elexity has. Like Casey said, our goal with these solutions has been to make it as simple and easy as possible to implement solar plus storage and provide that value. So, and there is a lot of value to adding storage like we've been talking about for these PV systems, really being able to take that, clean energy from PV and use it at the high demand times and not just, when the sun's out. So, we've deployed several generations of energy storage systems since around 2018. The first generation was about 30 kilowatts, 65 kilowatt hours. Our latest generation, I guess that's what's at Rancho Santa Margarita, is our 125 kilowatt, 279 kilowatt hour. And we're also launching our new 62 and a half and 125 Gonzo energy storage system that we're excited about this year. And then, I think I'd also like the audience to understand, what's important for these energy storage systems is really good integration between all the components involved, the batteries, the inverters, the energy management system, all the software. And we at CPS, we put a lot of focus in this, and we're now manufacturing battery modules, obviously the inverters, and the entire hardware package, while working closely with Elexity on the software side. And that's been really important, versus kind of taking different products, putting it together. We're really able to offer a kind of turnkey, fully integrated package.
I think many solar professionals today are familiar with solar and batteries, and every solar professional is now a energy storage professional. If you're not, you better get on that train, because that is truly the future in all markets across the globe. But Casey, energy management software is something that many energy professionals are not that familiar with, and it does seem to be a bit of a black box to us, I think. But tell us a little more about your system, and if you can bring it home to Rancho Santa Margarita, that's great. But just in general, what are some data points and strategies that are important for maximizing the value of this kind of an installation?
Yeah. Well, we have to think from a system perspective, and for the project developers out there, companies like Freedom Solar, right? I think need to be and are. That's why Ryan's here. Energy problem solvers for the customer. Thinking about the whole bill, thinking about grid services. And to venture in, to go from solar to batteries, that's one step. But if you take the step to think about being a problem solver for the facility and managing all the major energy systems in the building, you just get much more significant economic benefit by doing that. And you're going to deliver an experience to customers that really just, is very positive. You're going to delight customers. Let me talk about a little bit of the challenge and then the benefit of adding load control, for example. The benefit, Tim, you use the metaphor of the kind of thermal battery, and I'll just play off that as a simple metaphor right now. At Rancho Santa Margarita, we have a 125 kilowatt, 279 kilowatt hour battery there. By controlling HVAC, we're really adding another effectively kind of 50 kilowatt, 100 kilowatt hour thermal battery. So think of the math there. That's almost a 50% improvement in battery capacity by managing, a little less, like 40%, by managing the loads. And that just simply drives better economics. That translates to better savings. It translates to bigger grid services, revenue checks. That's the upside from a hard dollars perspective. I talked a little bit about the other upside for the customer is now they have, I'm picking up my phone, one platform to log in to manage everything. They don't need to go buy a $100,000 building management system from Honeywell to manage comfort and HVAC. They don't need to go buy an EV charger management solution. They don't need to buy these different packages and silos. They can get one platform. So those are some of the benefits. Here's one of the challenges, and I'll speak to it just frankly for the project developers that are going from solar to storage. Adding load control is a little bit of a head scratcher. Like, what, we're going to talk about HVAC? That feels like a bit of a stretch. But think of it the other way. You'd be crazy to not control something like HVAC, which is 60 to 70% of the load in most commercial buildings. You do that first. You do that in concert with a major investment like solar and storage. And we're really crazy as an industry to not be paying attention to the loads. And the rate structures and everything that's changing from a utility perspective is forcing us as an industry to go do that. So we just try to make that really easy for our partners. And once you do that, you really can get a delighted customer.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 8 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more. So Anton, tell us a little bit of, about what facility owners should understand. How do we size these solar and battery storage projects? And, is there an optimal solution, so to speak, for every facility?
Yeah, I think that'll depend on the facility, but with sizing systems, solar only is, relatively straightforward. You look at the building demand or load and you size the solar based on that. Now with adding energy storage, you then can look at, all right, when is the energy being used? How much is being used during these peak demand charge times when the facilities bill is significantly being kind of charged during those times, and then when is optimal to charge and discharge these systems based on those rates. So looking at offsetting the high demand charges that are huge for these commercial facilities, using the solar produced during the day, and using that during the peak hours where the value of energy use is really high versus the low value times during kind of midday. Or you look at providing the right type of backup or resiliency for a site. There's different applications for the solar and storage systems. And, I think looking at the site's interval data of exactly when, the energy is being used and what the right amount of both solar and battery capacity makes sense. I think, we at CPS can support on the technical side for the hardware. Elexity does a great job of looking at the economics there, doing that analysis, and really seeing what the economic value is and ROI. So yeah, I think it's something we can definitely support and make easy as you're sizing these systems.
Casey, we're getting some questions from the audience that really boil down to, could you describe the system to us? It would be great if you could just paint us a picture. What are the hardware and software components of the Elexity system, and how do they play with the battery and the solar? Oh, and the HVAC system, sorry.
Yeah, great. Appreciate the questions. Well, let's start with the hardware because that's maybe a little easier to understand. In every building, we put in a revenue grade meter that's measuring the total load or the net load, mirroring the utility meter. We optimize economically against the utility meter. So we put in a revenue grade meter to see that data and manage accordingly. We also connect to the solar system's output. We are monitoring that data. Of course, with the battery system, we're connected directly to the battery, and our EMS software is the supervisory controller of the battery itself. If the customer elects to go with load control, which is optional, right? We do quite a few buildings where it's, we're just doing battery management with our EMS software. But if load control is a good fit for the building, for HVAC, we connect to every thermostat in the facility. And we're sending just a supervisory signal to that thermostat to move it up or down. And we do that inside the guardrails that customers set up. So back to the software piece, for HVAC load control, our customers have a software platform to set temperature settings for every room, every zone, schedules, overrides. We enable them with a complete platform to manage that. And then we optimize inside their guardrails. We do that on autopilot. If there's EV chargers, they have an interface to our software to set up the chargers in a way that we know where we're allowed to throttle them back and control them. A car dealership may have a front of building EV charger that's for a customer, and they want that to just run whenever a customer needs it. But they may have a few level 2 or fast chargers in the service bay, and those just need to charge a vehicle overnight, and those can be managed more carefully to avoid peak charges. So we enable an interface to our customer to set that all up. Now, what does the software do? Like, what's the magic behind it? Well, we are using predictive control to anticipate peaks. We're connected to real-time pricing from the utility. We're forecasting weather and forecasting solar output. That gets all smashed in our AI engine to make decisions real time, every minute, every day, about what to do with HVAC, EV chargers, and how to deploy the battery. Let me boil it to maybe a couple simple examples. Pre-cooling a facility, let's pick Rancho Santa Margarita. Ryan talked about standing on the patio at 102 degrees in the middle of the summer. It gets hot there, right? Rancho Santa Margarita, we know their limits where they define comfort, and we'll pre-cool their facility within their limits, knowing we have high solar output at the moment and knowing the forecasted temperature will rise later in the afternoon, and allow that HVAC system to drift during that period of time to avoid a peak demand charge. And we can do that while keeping them comfortable. The magic here is you got to deliver savings. You can't disrupt business operations. And that trade-off, that's the secret sauce in our algorithm that we've built and invested heavily in over a number of years to get that right. And when you get that right, when that shows up, man, it's really fun. And I'm going to give one example. And sorry for taking the mic for so long, but I'm going to give one example of a fun moment. Another car dealership, another Toyota dealership in California that we control. We recently got to knock on their door and say, hey, here's a $30,000 check for the grid services program we enrolled you in. And they're like, wow, wow. What did we have to do to get that? Nothing. What did you do? Well, we optimized your HVAC. They're like, well, did you make us? We weren't less comfortable, right? We intelligently did that in a way inside your guardrails every day on autopilot. You didn't have to think about it, and a check shows up, right? Now that is fun, and that's the kind of output you get from a system like Elexity.
We have plenty of time for more questions from the audience, so please do put your questions into the Q&A, and we'll do our best to get to those. Thank you for that, Casey. That was a good overview. I wonder, Ryan, can you speak to the customer's perspective a little bit more and how that conversation and implementation went, as far as how were they able to understand this value proposition, and how did they tackle, this second phase of the project of integrating the battery and the Elexity system?
Yeah, and based on some of the questions that I'm seeing coming in, there's kind of a story here that's playing out in the same way in front of me, and that is that we can be such technologists and tinkerers and so curious on the nooks and crannies of the technical aspects on everything, how everything works, and that is repelling for an awful lot of the client perspective, because they have their own lives. They're very busy. They're running their own business. So in thinking about the misunderstandings, we really need to have that bullpen of facts, and when and if they want to drill down and get into the details of the technology, we can do that. But we like to keep things in a very simple, eyebrows in the middle of your forehead, just keep it real easy and light. And this is the path that's inevitable for you. Going back to another problem, when you look at last month's utility bill, you don't know what happened. You just look at it, all you know is that's a lot of money, but you can't decipher it. You've got transmission charges, distribution charges. In some areas of California, you could have 6, 9, or 12 different schedules for peak demand charges. I mean, it truly is a migraine headache waiting to hit you. So the solution really starts with, where there's pain, there's opportunity. And the pain is, what is going on here? And we know that it's mass chaos, there's confusion, and I have to pay that bill. So the next step is, how do I fight back? So it's very simple. On-site power production with on-site power storage is functionally and financially the way you fight back. And then, oh, by the way, because you are running a business and you can't figure out the calculus problem that's on your utility bill, why don't we have AI-powered software that just does that heavy lifting for us? And I love when Casey says, let's just put it out on autopilot. On my home system, I've learned something very simple. If I can get the house cooled sooner in the morning before the peak demand times hit, by 1, 2, or 3 when it's hotter, I'm just maintaining. I don't have to play catch up. I'm learning that just in my home system. Well, geez, when you're talking 50, 60, 80,000 square foot buildings, I need on-site power production, I need on-site power storage, and I need someone else driving the ship for HVAC and optimizing everything else that is monitoring the time of use charges that are coming, as Casey said, minute by minute from the utility company. So that's the whole process. So, if they want to get into the technical aspects of what's the wind load rating, what's the weight, can it take snow loads, what do inverters do? Sure, we can geek out on all that stuff. But the reality is we have one thing to solve, and that is, how can I fight back with my utility bill? And then keep it simple.
So we have a couple of
tack onto that.
Yeah, go ahead.
Yeah, and Ryan is so good at speaking the customer language and simplification. I want to center on one thing as an example. Back to that demand charge, it's the worst 15-minute spike in an entire month or a billing period. Just one 15-minute interval that can be 70% of the bill. Imagine running a school with a couple 100,000 square feet with solar, battery, hundreds of HVAC systems, or a car dealership with 20 HVAC units and a battery and doors opening and closing and customers coming and going and EV chargers turning on and off. There is no way this customer could manually manage that. It's impossible. Let software simplify that challenge.
For sure. And we have a couple of questions from Craig Lewis, who is a friend of the podcast and was a guest on episode 160. He's the founder of the Clean Coalition. Thank you for being here, Craig Lewis. And for anyone who's not familiar with the Clean Coalition, please check them out. They are building community scale microgrids, mostly on the West Coast, but working nationwide. And there's two questions. One for the team about this project, and is there any kind of a public case study that people can learn more about this project with?
There is not yet, but
okay.
There will be one.
Great.
We do have a couple case studies that are similar that are on our website at elexity.io, but This one is to be published.
And then in this case, or in this and other cases, is this project a microgrid in that it can isolate from the grid in the case of a grid outage? And is there a consideration for the value of resiliency?
This project is an on-grid project. The location here, they just got very limited outages and very high utility bills. So the focus was clearly on bill reduction. But our collective system can support a microgrid or a hybrid. Hybrid meaning on-grid most of the time, and when there's a high risk of an outage, whether it's from weather or other inputs, allocate some of the battery capacity for backup. So that's certainly possible. But this project is just an on-grid project.
Very well. So
yeah,
we have about 10 minutes left. You had something to add, Anton?
Yeah, I was just going to add, like Casey said, the system does have the capability of, a microgrid application or a backup application. And we are starting to see a lot more and more of those types of projects, depending on what the needs are for the system or what the customer is looking for. But it is a different, calculation versus, really focusing on lowering those bills, which is a huge, challenge, like Ryan and Casey are saying. A lot of value there versus the value of backup and resiliency, which there's a ton of value there. It's just a different, financial calculation.
Understood. I'm just looking through the questions, and I want to thank Dr. Z for also helping me sort through these questions. He's in the background here from CPS. There are a lot of questions about hardware, and Casey I think one of the important things for us to understand is off the shelf versus a custom box, so to speak, from Elexity. What all is entailed in an Elexity installation in a project like this?
Yeah. From a hardware perspective, it's one standard. It's our EMS controller box. It's, this side, it's, a couple feet by a couple feet. It's small. It gets mounted in an electrical room. It has our meter hardware in there, our communications hardware. There are CTs that connect, to both the solar and the building load. The other major piece of hardware is the battery system, right? And it's as simple as that. Many buildings already have smart thermostats or a building management system, and we're just communicating to that through our controller. This is not open heart surgery on an HVAC system in a building, right? We're not replacing major components there. We're simply communicating to the existing systems that are there. Sometimes we need to, the customer needs to upgrade to a smart thermostat. There are a lot of buildings that are guilty of having push button thermostats that have been there, for 25 years. So sometimes an upgrade's needed there. But from a hardware perspective, it's relatively simple. The battery and our controller.
And can Elexity be retrofitted? This is a question from Phil Suna, another friend of the pod. Shout out to Phil. Can you retrofit Elexity on top of an existing PV and battery storage system?
You certainly can. Yeah, we're the supervisory EMS layer. And we can go in and integrate with an existing battery, and then integrate again with the key loads in the building. So the answer is absolutely yes. We've designed our system for just that purpose.
Cool. And a question for Anton from a colleague of yours in Pakistan, who goes by the name Bucker. Bucker, they're introducing battery storage into the Pakistani market. One of the drawbacks is the number of cycles that we use. And cycling batteries is definitely a question that comes up. It can impact the warranty. But do you want to speak to cycling and maybe what is a best practice if you're an installer thinking about these solutions?
Yeah. As far as the battery warranty, ours, and I think most battery suppliers have, not just a time, a number of years that the batteries are under warranty, but a number of cycles. And for most of the applications that we've seen today, it's one cycle per day. But the inverters or the batteries do allow, more than that. You just have maybe a shorter lifetime or, shorter time for degradation of those batteries. So yeah, I think, the message is, look at the battery warranty terms. But, typically if it's one cycle per day, you've got the standard, length of the warranty period. And then I was just going to add to the question on hardware. I think early on when energy storage technology was coming out, a lot of, engineers they'd have a battery and a bidirectional inverter, and they were figuring out how to put it all together. And then they had an EMS to manage it all. And it was a little bit of an engineering experiment. Whereas today, with solutions like what we have, where it's a fully integrated batteries, inverters, all tested, certified to operate together, and communications all optimized there. I think it makes it really easy to understand and I guess have that solution that's like, this is what it does, this is the benefit, and not having to go into a lot of those technical weeds like Ryan was saying. A lot of the customers or the owners don't have the time or really want to go into all that.
Cool. We have a couple of questions from Kusai, who's also a friend of the pod. Shout out to Kusai. I had lunch with him just a couple of weeks ago in Southern California. 2 questions. Did you add CTs to every breaker on every sub panel? So question about the hardware. And then did the utility, what kind of utility permission is required to install this kind of a load control system, if any?
Great questions. We often get that question around installing sort of sub-metering or breaker level, measuring and monitoring of HVAC. We don't have to do that. One of the beautiful things about the capability of software with the ability to learn behavior and characterize behavior in a building is that you can, over time, learn the relationship between the energy signature and the specific unit you're controlling, and build that relationship through software. We know, for example, in every building that we're in, the power signature of every single HVAC unit that we control and the amount of energy it needs to heat or cool a room by a degree or two. You can learn that, and that avoids considerable cost to install unnecessary monitoring, frankly. So that's I guess answer to question number one. Tim, what was question two again? Utility permit?
Yeah, is utility permission required?
Not for the load control piece. All we're doing is making the building more efficient, right? Shifting the loads, no utility requirements, or permitting requirements for the installation of load control. We do use an electrician to install the meter at the facility. And so, whatever local codes are required to be able to do that, need to be supported. But no, this is not an interconnect application process or a utility process for the load control piece. Of course, for solar and batteries, the answer is yes. You got to go through a process there.
Great. And then I think a very important question from Dave on, do you think about other energy efficiency aspects of the building when you're going into a project like this? Do you do any kind of a base level energy audit, and then have you, do you often want to consider upgrades to the facility?
Great question again. We do. So part of our process, when we get installed with the load control element, we go through a learning process. We learn the behavior of the building, and we produce a systems health check for the customer. For HVAC, we'll tell them, give an example. We have a school in Southern California, J. Sarah, 117 HVAC units. They get a report that says, here's the performance of each of those units. Here are the units that might need some repair, not able to keep up with temperature, right? So pretty significant value add there. In terms of efficiency, here's the truth. Most commercial buildings are poorly managed today. And there's kind of low-hanging fruit around efficiency by just getting them set up on schedules and eliminating dumb energy mistakes through our automation that drives efficiency. The last person to leave the building on a Friday afternoon sets the temperature in an HVAC unit to 68 degrees, and it runs all weekend with nobody in the building. We eliminate all those dumb mistakes. And sometimes that's 5 to 10%, maybe sometimes more of the bill. So that is part of our setup, and that's in addition, and then above that, we do the demand management work. So certainly we start with energy efficiency. We're not doing lighting and other things. We're really focused on the major flexible loads like HVAC and EV chargers in the building.
Great. Well, I'd love to hear any closing comments from our panelists. I want to thank our listeners and audience for being here and for all your questions. Any closing remarks? You have to make them very brief. But yeah, we'll welcome Anton, Ryan, and Casey to make any closing comments.
I'll go just real quickly. I talked about the phased approach, and that's important from the client perspective in that they don't have to be psychic. They don't have to anticipate what are the problems I'm going to be solving 2 years from now that I should be addressing today. So what I'll liken that to is, maybe 10 years ago when commercial green efforts were out there and, how can I run my business and be more environmental? I mean, there was really silly things like, can you compost your your coffee grounds, and these really small, inconsequential things that truly were greenwashing. So when you look at a phased approach, you do follow the money, and what you can end up doing is being a little more patient and realize, okay, what's the big sledgehammer thing I can start with? And that is a financial decision. Like, what's obvious or inevitable? Let's tackle that. And then how do I find the truth on what's the right combination of technologies that I'll be adding to that? So I think Anton brought this up too, it was 3, 4, even 5 years ago, it was the wild, wild west on how to Frankenstein a system and put it together. And no one knew there was just too much chaos. That's all calmed down now. So why we really do like this Rancho Santa Margarita example is it was not heavily subsidized at all. It was just the function of the technology that was solving the problems, and they did it in a nice, patient way. And here they are with a built-out system where they don't have to worry now. It's when they read the news about net metering 3.0 and all those they don't care. They don't want to sell energy back to the utility anyway. They want to store it on site. So here they are at the top of the mountain, but it took them a while to climb it, and they were not sweating when they got to the top.
Yeah, I can go next. Yeah, I guess start with thanks, Tim, and everybody for having me on this webinar. But I think a closing remark is, with the changes in utility rates, and kind of the industry trends, the energy storage piece has been kind of a key next step in the clean energy transition. Solar only has been becoming, more and more challenging to pencil economically on its own. And adding energy storage, the solutions are there. And we have solutions that are great fit for the commercial market, paired with the Elexity energy management system. So if you are working on a solar and storage project or a solar project and it's difficult to pencil, reach out to our team. We can go over the solutions we have and the value they can provide.
Yeah, I'll be brief. I know we're at the end of the hour. You heard a bit of complexity today. Our aim, particularly CPS and Elexity, we are trying to, the complexity is there, it's real, like managing these complex rate structures, but the solution, we're focused on making that simple to design with, install, and to delight customers. And that's kind of the mission we're on, and we'd love to help you get there.
Well, thank you all of our panelists, Ryan Ferrero from Freedom Solar, Casey Miller from Elexity, and Anton Patton from CPS America. I put their LinkedIn profiles in the chat, and we'll put those in the show notes as well. So please connect with them on LinkedIn. Check out all of our content at cleanpowerhour.com. If you're listening to this on Apple or Spotify, please give us a rating and a review. And of course, follow us on YouTube. Tell a friend about the show. Connect with me on LinkedIn. And with that, I want to say thank you to CPS America for sponsoring today's event. Go to chinpowersystems.com for more information about their 3-phase string inverters and battery storage for all of your C&I and utility scale project needs. With that, I'll say, I'm Tim Montague. Let's grow solar and storage. Thanks so much, everybody. The Clean Power Hour is brought to you by CPS America, maker of North America's #1 3-phase string inverter, with over 8 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more.